Hey everyone, how are we doing? We got Cameron here, we got Jennifer here. What questions are there? I've got to get the music going on here. It's so much, we're almost fixed up on this. I was working on quiz 2, question 2. I don't remember if we talked about finding the IQR and the quartile and stuff. Let's go look at that right here. Let's go find the IQR and the quartile. It's so funny, it's like, don't shave for one day and I'm like, wow, one day. No, that's excellent work right there, Cameron. What does the question say? Can you tell me more in depth? Like the question starts with this because question 2 is actually different for everybody. So everybody gets a different question 2. MuBot's officially here. So if you go points, I think, did we get to the IQR? We started talking about the standard deviation, I think, to end. I'm not saying bad gateway on my Pearson. Come on, my Pearson, log in. I've got a lot of points if you can't tell. I've got hashtag show up to class level, 1.3 points. I guess maybe we'll keep that in there as a little, see, I said 1 point this semester, but you know, I've already got 1,000,000 points because I've been here a while. Am I playing music? If you hear music, it is because I am playing it. My in-ear audio doesn't work yet. We're through the final completion of this studio. So you should hear music. I think you should be hearing it. Do you hear music, Cameron? Do you hear? I can stop it. And there, guys, stopped it. No questions at the moment. I'm sick. Oh, sorry. Tornado deaths. Feel better, Jennifer? Sorry about that. The tornado deaths one. Let's go look at that. And let me get the notes. You shouldn't hear any other things through the live stream. Okay, we're gonna put the notes for the video right here. And now we're gonna bring up the tornado question. And let's see. So you should have been hearing music, I would hope, because I was playing music through it. But tell me if you ever don't hear music or do hear music. You won't know if you're not hearing it though. Like, I don't hear the music, Brian. Well, yeah, no, well, I'm playing some right now. Do you hear it, Cameron? Do you hear music? A little nice chill music in the background. It's registering on the stream I see over there. So usually I have in-ear audio so I can hear what you hear, but I can hear it, it's nice. Yeah, it's like, it keeps me chill too. And then I kind of moderate my voice to it. So I'm getting the questions loaded up. Like, is Brian playing music? Question number 2. Okay. As we talk about tornado deaths, fun stuff. Question number 2 should be 4 through 6. I guess that kind of helps. Traffic fatalities, body parts. Okay, is this the tornado? Here, we'll go to the main screen. Let's check it out. So here is the tornado one, and with the tornado deaths right here, is this the tornado? This is a different one. Let me change what it says right here. This is traffic fatalities. And it might be tornadoes, because sometimes they change context. I don't see it. I think it's question 2, and that's body fat. Count them. Emails. This is emails. I'll look through here again. Do you see it, Cameron? Mean IQ. Yeah, I think there's some down here which have find all those values. We're gonna show how to find those values. Let me find one that has you go through and it shows the data, right? It actually gives you data and says find, oh, this looks about right here. Okay. This is the one. We found it. So it was more towards the end. I think it might randomize your questions, so you might not always have the same ones in the same spot. So let me put this in the notes. I'm getting Jump and everything opened up in the background right here. Jump 17 Pro, opening up a Word document, and we're gonna take a note on this. We've got so many just random lines drawn on the screen. It is currently 7:53, and this is chapter 2 quiz, tornadoes. Okay, so we're gonna close out all those documents that I don't want anymore. You'll see me here in a second. Here I am, and so let's take a look at this question, and Jump is open, should be in the background. Okay, with this question right here, what's it originally asking us? It's saying, here's a data set, right? So this is the data you're using. So take a look at this data right here and notice that there's a lot of what values immediately. What do you notice right here? There's a lot of what values. We're doing some review. You want to look at those values and be like, there's a lot of very what values here. Like 26, 83, 24, 296, 313. So just kind of thinking about the data and the way it looks, what do you notice? You always want to look at your data, understand your data first, and then go from there and do the next question. Be like, okay, so how's this data look? These are key concepts that could be on the test. It's a lot of low numbers, wide range, right? So there's a lot of low numbers, and then there's some high numbers. So when you think about it, it's piled up on the low side and there's high numbers. This is going to be right or left skewed data. So can you figure out conceptually if this is right or left skewed data? We're going to go right here to copy the data, copy to clipboard. Once we copy to clipboard, we're going to hit Control or Command C. This is recorded if you need to slow it down. And now that we've copied it, we're going to go over to Jump, which is open now. And inside of Jump, we're simply going to go to, close out of the tip of the day, we're going to go to File, New Data Table. File, New Data Table. I'll get to it eventually. There we go. File, New Data Table, or Control or Command N. Once we're inside of here, I think there's no column header to this one. There's no top to it where it says like Tornado Desk. We just go here now and go to Edit, Paste. If there was a column name at the top, like where it said Tornado Desk, we would use column names. Make sure this pastes as quantitative, and you can tell it's quantitative in Jump because it's blue. I want to make sure you see that right there. That little blue right there is quantitative. You don't have to do what I'm doing here. I'm just showing you that if you were entering something like A, it would turn it to categorical. That's just an example to show you the icon on the columns over there on the far side show you what kind of variable it is, the type of variable, where we have here a quantitative column versus a categorical column, and specifically categorical ordinal. So you can even change them by clicking here and changing the different type of variable. So we know we have data in Jump right now, but now we need to analyze it. Well, let's analyze it. To analyze the data, we're going to go to Analyze Distribution. Analyze Distribution. So all I'm doing is just clicking the top, Analyze Distribution. With Analyze Distribution, we're not going to check for updates. That's random. Analyze Distribution, we're going to pick the variable. And so here's the variable we want, and just put it right there into Y columns. You can drag, drop, or double click, and then click OK. Now, what do you get? You get a histogram, which is a univariate display of quantitative data. You get the 5-number summary, which we're going to talk about today, the min, the max, the Q1, the median, the Q3, and you get some summary statistics. To make this easier to view, let's click the top red arrow and click Stack. The top red arrow is where the options are for the graphic, and the second red arrow has more options specific to changing the graphic itself too. Let's go here. So the red arrows have your options. If you're looking for options, click the red arrows. We're not going to click a whole bunch right now, but if you ever want to change things on your graphic, the red arrows are where the options are at. The gray arrows close the graphics, so I wouldn't suggest clicking those. But very clearly, Cameron, this distribution is what skewed. Very clearly, this distribution is what skewed. Very, very clearly. Remember we said there's a lot of low numbers and very few high numbers. Right skewed, right to the high, left to the low, whatever way the monster man's tail goes. So it is a right skewed distribution. We still have snipping tool. Let's try it. We always draw our monster man to remind ourselves right to the high, left to the low, whatever way the monster man's tail goes. And we're just going to highlight this right here. We're going to find our pen and try to draw a nice little monster man on this. There, oh, look at that. Is it? Oh, pen's still having a little bit of problem, but there is the monster man, and there is the monster man tail right there. Right to the high, left to the low, because the monster man's tail goes to the high side, the right side. Monster in the chat right there. Let's throw you some 50 points for that. So with this, that is a right skewed distribution. Now, since it's right skewed, will the mean or median be higher? Since it's right skewed, you can cheat and look at the data. Since it's right skewed, will the mean or the median be higher? I'm not blocking anything important with my head, but since it's right skewed, will the mean or the median be higher? We're doing test question review right now, concepts that we should know. Thank you, Zach, right there with those more points. The mean, because the mean follows the skew. That's a good note from class right there. And you can see it right here. The mean is 104.9. Sounds like a radio station. And the median is 73. 104.9. The University of Tennessee. Got WUTK. And so the mean is higher, the mean follows the skew, the median doesn't follow skew. The median is that line in the middle of the box plot. We'll talk about that more today, that line right there. And the mean is actually the center of the diamond. Not usually shown in box plots, but Jump adds some extra details, like the mean being the center of the diamond. So this is a lot of the values. Does that make sense, Cameron, right there? Like this is a lot of the values, the mean, the standard deviation. So yes, the median would be the proper measure. And then the IQR is the range of the middle 50%. The IQR stands for the interquartile range. There are 4 quarters in a data set, and the interquarters is the middle 50%. Like if you have 2 quarters in the middle, that's 50%. So the interquarters and their range. And the interquartile range is not the range of the full data set, but the interquartile range is going to be the range of the middle 50%. So there is the interquartile range, and there's the range. So this is the range, and this is the IQR. So the IQR is just the range of the middle 50%. So think about this. What would you do to find the IQR on here? Mathematically, if the range is max minus min, mathematically, how do you find the IQR, which is the range of the middle 50%? The interquarters range, the middle 50% range. What would you do mathematically? And this is where the learning comes into play, to be like, oh, the IQR is the interquarter range, the range of the middle 50%. If you have 4 quarters, the inter ones are the middle. So the middle 50% is going to be the IQR, and then its range. Boom, Cameron, right there. You got it. Worth some 50 points. Just subtract. It's the range. It's big number minus small number, right? Like the formula is technically Q3 minus Q1. I mirror image these days. So it's technically Q3 minus Q1 because that's the 75th minus the 25th percentile, because 3 quarters is Q3 and Q1 is 1 quarter, Q1, 1 quarter, 25%. So Q3 minus Q1, or big number minus small number, I like to say, just like max minus min. You can also cheat. Yeah. Well, here's another way to cheat, though. Not really cheat, but you can go here to summary statistics. And in summary statistics, you can customize them and include the interquartile range and the range. Like, just in case you want to make sure you don't make mathematical errors, you can put these on it. And guess what? You were 100% right there, Cameron. It's 98.5, and you showed the formula, but also JUMP can get you these answers. So if you want to use JUMP using customized summary statistics right here, just go to customized summary statistics and you can add a lot of things. It is. And this is why some people say, why do you use statistical software? Well, it makes it easy. Because you're just like, oh, what's this? You just have to know what it is, though. Like, well, what the heck is the interquartile range? What is kurtosis? What is skewness? What is autocorrelation? So autocorrelation is correlation on itself. Corrected, sums of squares. Uncorrected sums of squares. I think that's what SS is right there. Lots of things. Even robust mean. So that's robust to outliers. So there's a whole bunch of things on here which I kind of know, but I don't know them all. I know most of the terms on there. And that's what we do in statistics, is we come up with ways to describe data. And these are kind of the basic ones a lot of people use, like mean, standard deviation, median, IQR, but there's always new things. So that really, this is all the answers. I'm gonna go ahead and take a screenshot of this, because we should have most, if not all, the answers. So how is this question a lot easier now, Cameron? What do you think? A big portion of our class is understanding what to use and when. Like, why do we use the mean? Why do we use the median? The mean is used for normal data. The median is used for skewed data. The mean is used with the standard deviation. The IQR is used with the median. I think I said everything right. I was kind of getting this ready, and also, there we go. Let me disappear so we can see the answers on the screen. The mean is 104.90. The median is 73. We know that the mean is higher than the median because of the skew. The first quarter of the data, which is after you go through 25% of the observations, is Q1. Q3, which is the top 25%, or after you go through 75% of the data, because Q3, 75% of the data has been gone through. The range of the data is the max minus the min, 313 minus 24, which we also calculate over there. And the IQR is the range of the middle 50%, which you showed on the screen, 135.5 minus 37, 98.5, the range of the middle 50%. And that's got it. So once again, you should know terms for this. Let me repeat what these things are again. The mean is the average. The average tornado deaths in a year was 104.9. Since the data is heavily skewed to the right, the median is probably a better representation of the center of the data, and the 50th percentile of tornado deaths was 73. Notice how I say the 50th percentile, because that's what the median is. The 25th percentile of tornado deaths is 37, Q1, 1 quarter. The 75th percentile of tornado deaths was 135.5. This is also the top 25% because you've gone through 75% of the data, so you're on the far right side of the data on the higher end. The range of the data is the max minus the min. We could look what those values are, but the data has a range of 289. The distance between the max minus min is 289. That's the range of the data set. The interquartile range is the range of the middle 50%. The middle 50% spans 98.5, so the data is spread out 98.5 across the range of the middle 50% of tornado deaths, found by the formula 135.5 minus 37. You'll be describing data in some of your visualizations, and notice how I say it in accordance with tornado deaths when I'm describing this right here. So it's not just about finding these values, it's understanding what these values right here mean. So we're not just finding things, we're interpreting them. Which one do you want to do next? That was a really great question. We definitely, let's knock out some more. Let's talk about what the data means, because it's not just about getting the answers. It's like, what is the IQR? What is the mean? What is the median? What is the range? What is the standard deviation? Standard deviation is just a measure of spread. We'll never find that one by hand. But give another question, which one you were in. Question 6, 4-mile run over 10 years. Yeah, just keep, if you're here, you get to get all your questions done. And so I'll tell people, I'll be like, show up. And thank you right there. Always with the start, my Pearson's being weird now. It's with the 4-mile run over 10 years. And if anyone has questions, you can just say the question anytime, and then we'll put it in the list of questions to do. 4 miles run over 10 years. Where is it? 4-mile run over 10 years. Oh wait, there was. I literally was on it. Okay, let's put it in the notes. And 1953 chapter 2 quiz. And this is an author collected. Okay, an author collected times in minutes it took him to run 4 miles on various courses during a 10-year period. The accompanying histogram shows the times, describe the distribution, and summarize the important features. What is it about running that might account for the shape of the histogram? Now here's the thing, this is kind of a time series. So I think I sometimes get this one wrong on the multiple guess at the end because it's a little bit weird. So think about this. Like, I used to run, but as I get older, Cameron, what's going to happen to my times? What's going to happen to my times? Because this running data is like personal to me. And he's seeing how long it takes him to run 4 miles. So at the end, he was almost doing 7-minute miles, or we don't know if that's the end because he might have started out, maybe got injured, maybe he wasn't doing it. You might slow down as you get older. You kind of peak in your physical physique in your 20s or so. Like, that's when you see a lot of Olympians. Like, I mean, there's Olympians in their 30s, 40s, 50s, but when you get to like 50s, it's like curling you're doing. You're not doing, you're not like a sprinter in your 50s or 60s. And kudos to anyone who's doing that, because they actually have Olympian people who do it for older age groups. But you're not competing against like 25-year-olds or 24-year-olds. It's usually peak. So it just depends on where they were at. But I would assume they started, I think the goal of this is they started like, it should say they started in their 20s. And they ran 4 miles every day for a while. Because probably they went towards here, like they were a little slower to begin with, and then they went towards here. What you'd want to see right here is a time series, I keep saying. A time series or a time plot, I'll show you this right here, is a bivariate display. So it's a scatter plot with time on the x-axis. So what it would look like, if you think about it visually, this is the proper display of the data. We'd have this right here, and their times would probably start to go down like this. And maybe they start to get a little bit older and they start to go like this, but this might be like 34 or something, and this might be like 28, and then all the way up here to 38. Does that make sense? That's a 10-year period. Just a quick scribble of what it would look like, and their time is decreasing. So this is what we call a time plot. Like as they get older, like each year, we could put it by year of the calendar year, or we could do it by age. So it's kind of more of a time plot if we do it by calendar year or by day or whatever they did. But that right there is going to be probably a better display. The histogram only shows univariate. What were their times? So describe the distribution. It's definitely what? 100% what? Once again, think about the Monster Man. We shouldn't even look at the answers. It's similar to the last one. Describe the shape of it and think about your Monster Man. Here's the Monster Man. Nice and easy Monster Man to draw. Skewed to the right, definitely. And then also, I think it might have mentioned this right here, which is unimodal, one peak to the Monster Man. So let's see what it says regarding this. It is skewed to the right. It is unimodal. Uniform is flat. Multimodal is multiple bumps. And bimodal is two, bi and unicycle, bicycle. Bicycle. It is centered at around what? So usually the mode is the place it's centered. So we're looking for an answer in this region, probably close to 30. The modality of it gives you an idea of where the center of the distribution is. So we're probably looking for a center around 30. And this looks, see, I'm a little worried now. A little worried. Yeah, let's look again. Yeah, that's iffy. Is there a 30 through 31? Oof, that's okay. Wait, let me look again because now I'm a little iffy on this. I'm actually, if you look at it, I'm gonna go 30 through 31 on this. Truthfully, you could email me on this. Yeah, that looks to be a little more the center. That's such an iffy one. 30 is a better answer, but if we look exactly where this peak is at, that would fall into this bin right here or that area. So if we look exactly where the peak is, it's between 30 to 31. That's it's around 30. Like if I once again realize that they're just giving you options. So if I were to answer this, I'd say it's peaked around 30 or the center of the distribution is around 30. So yeah. What is it about the running that might account for the shape? Okay. Whew, this is the subjective part. Oh, with most observations between the center, I think it's 29 to 32. Let's look at that again. 29 to 32. Yeah, look at that. 29 to 32. What are the other answers before I do the next question? Because I didn't even see that. 29 to 32 looks about right. 33 to 36, no. And 28 to 30, no. So 28 to 30 is another answer. And that'd be no right there. 28 to 30, no. And then like, no. Those are not right. Not right. It's 29 to 32. A lot of the times are there. So once again, this is what we have. We have a unimodal right-skewed distribution with some outliers on the high side. We have the center of the distribution is close to 30, with the IQR maybe being between 29 to 32. And we could do the mathematics to find out those answers, and the range being like 28.5 to 35.5. We could subtract those and get a range of about 7. This is the subjective hard part of it, but once again, you get to see the answers right here, and I've got a lot of videos if you find other subjective ones. What about it might account for the times? Over a 10-year period, the runner's times may have improved. Totally possible. It is easier to run much slower than normal, but harder to run much faster. Is it easier to run slower? Yes. Is it easier to run faster than normal? No. Over a 10-year period, they may have slowed down due to injury or aging. Totally possible. We should get it all right. No. I'm thinking it's one of these. See, this is where it's this one because it's the way. See, that's nonsense. Like I said, I remember this one. I know this one. I had no question on the other parts, but I remember this one from years past. If you got this wrong, you can always email me or email your instructor and be like, someone could probably improve over a 10-year period. But I guess they did 10 years because unless you started, it says an author. So they want you to think, what a 12-year-old could be an author, right? So you could be like, what if they were 12? What if they were a published author at 12 and they were tracking their times? You can still improve over a 10-year period. You kind of peak. Does it say they did it every day? So that's the thing, is you could improve. So yeah, I know that's why I do a lot of these. I was like, it's not easier to run much faster. And that's the subjective ones that are just like, they're the hardest part of doing any of these questions when it gives you a subjective thing. And those are the ones you can easily argue with me. Like if you get the mean wrong or the median wrong, I'll be like, recalculate it, get it right. But if one of these occurs, then just let us know, because we always try to get one wrong during office hours. I think last office hours or last class, we got like the first one wrong, then we got like 50 right in a row, but we get one wrong just for fun. What should we do next, Cameron? Knock out another question right here. Which one are you working on? See, if you're in office hours, you get to do it right here and get it right and know you're right. So advertisement for office hours. I hate those subjective ones. Like, why do you think it's like this? I don't know. Maybe they got better. Maybe they peaked in their performance. So they would improve, but they'd probably peak. And that's kind of what I was showing right here. Like over a 10-year period, they would probably improve in their performance. Depends on when this 10-year period is. But still, like, if someone started running in their 50s, they wouldn't like start getting worse every year. Like, they would get better. This is how it would look. They'd get better in their times faster. They'd peak, and then age would start to push against them. Like, they'd get to optimum age performance or close to an optimum performance at that age, and then they would stay at optimum performance for a different age. And yeah, age is not a fun thing. What else should we do? If you're in the chat and have questions, let us know. Life expectancy at birth. Oh, fun questions today. Life expectancy. Where's that one? Where is it? How does it start out? One of the very first few words of the question. That's and good question right there. That's the easiest way for me to find it. The life expectancy at birth. It has two parts. Two parts. Life expectancy. And my goal a lot of time with these questions is to show you how to do them, because there's so many, as you can tell right here. And so if you know how to do a lot of them, you can do any of them because they're very similar. So good questions. Oh, wait, here we go. The accompanying histogram shows the life expectancy, or let me mark the question first. We got an easy one. Let's do this. I like some easy ones because I got one wrong, right? So let's do an easy one. No one's ever been like, does he know how to do this? I make that joke because that was something a student said to me in my first year of teaching. They said, do you know how to do this? Like, because I got something wrong. And I was like, oh my gosh. Got me nervous. Let's see if I know how to do this one. The accompanying histogram shows the life expectancy at birth for 190 countries as collected by an international health agency. Would you report the standard deviation or the IQR? Standard deviation and IQR are measures of what? This is a keynote, you should know this. Standard deviation, IQR, and range are measures of blank of a data set. So standard deviation, IQR, and range are measures of blank of a data set. Have this note if you don't have it written down. Standard deviation, IQR, and also range are measures of this of a data set. 6-letter word. Starts with an S. Trying to jog your memory for watching this in the future, looking for the answer right here. Standard deviation, IQR, and range all seek to understand and measure the spread of a data frame. Now, why would we use standard deviation? Why would we use IQR? It's all based on the shape of the data. So the shape of the data dictates if we're going to use IQR or standard deviation. When data is normal, the correct measure of spread is going to be standard deviation. Normal means kind of unimodal symmetric, like the bell-shaped curve. When data is skewed, has the big tails we talked about with the Monster Man, well, that's going to mean we use the IQR as a measure of spread. So let's look at the data. Is this skewed or normal data? What do you think, Cameron, right there? There's a Monster Man here. Let's draw our Monster Man, and do we see a Monster Man tail? So is this more normal data, which means it's unimodal symmetric, or is that skewed data? Is that normal or skewed data? What do you think? Normal or skewed? Normal or skewed? How does that data look? It's skewed to the left, skewed to the left. So since it's pretty skewed data, the proper measure of center will be what? And this, I think it's a really good question. Like some questions I love, this one is one that I love because report, since it's skewed, what should we report? We'd say the proper measure of spread is going to be what? Since it's skewed. IQR, since the distribution is skewed. Literally, this is such a good question because it's exactly how I would say it. When the question agrees with me, it's a great question. Great work right there and good practice. If the distribution was more normal, we would use the standard deviation for the measure of spread. Remember, there is a measure of spread and there's a measure of center. Remember, proper measures of center and spread are based on the shape of a distribution. What we got time, just knocking out questions right here. Gonna try to get, it's been, we've had some people show up to in-person office hours, online office hours, but anyone can show up. I'll be reminding people during class today, say, hey, at any time, just swing by, come by office hours, say hey. So which one should we do next, Cameron? Give another one. Easy question, hard question, 10 parts, 2 parts, 1 part. There was another one with the same problem. Yeah, let's look at it. So it's probably gonna ask the measure of center, I bet. So I bet it's, here's another one. But then here, fine. There's a lot of the accompanying histograms. So this is, well, it's very similar. Trying to find exact, like the accompanying histogram where it asks like the proper measure of something. Some bar chart stuff. We haven't done categorical data yet. Let's see. If I see another accompanying histogram one, here it is. Good. So this is basically the same thing. Would you do, so when you think about IQR and standard deviation, So tell me, Cameron, how do we choose between IQR and standard deviation? So how do we choose between IQR and standard deviation? Because that's all this question is asking. It's just asking, how do you choose between IQR and standard deviation? The way to choose between the IQR and the standard deviation is simply look at the what. The way to know, is the histogram skewed? Is it normal? Does it have outliers? And this is a dot plot technically. And oof. Now I'm a little scared on this one. This is one of those iffy ones. Okay. So I'm going to draw over it. What do you, I think that makes it a little more clear. What do you think, Cameron? What do you think? Skewed dot plots on here? Skewed or more normal? Nothing's perfect in this world. Just remember that. Is it skewed or more normal? Skewed or more normal? More skewed or more normal? Remember, nothing's perfect. It's never, this is a good one and it's an iffy one, but it's, I would lean towards more normal, exactly. We can't put a good, like, which way does the monster man go? It's very hard to tell because this doesn't look like a good monster man versus the monster mans we've seen in previous examples. Like this one right here is a really good monster man if you draw the tail on that. So let's go right here and say report, since it's more normal, the standard deviation, since the distribution is more symmetric. Unimodal isn't really important because this right here is unimodal, but it's skewed. Now, I do want to point out there is a trick, though. What we could do, it is unimodal, but unimodal won't decide it because this is unimodal and the other one's unimodal. So unimodal is not the deciding factor. Does that make sense, Cameron? So they're trying to trick you. It is unimodal. That is a fact. But that's not a deciding factor on what to report. The deciding factor will be the skew or the symmetry or the presence of outliers, which this one right here has outliers. So the reason we're doing IQR with this one on the screen now is because there's outliers and skew, not because unimodal. And the reason we're doing the standard deviation here is because of the symmetry. Unimodal has really nothing to do with it. It does have the same prompt at the start. Since the distribution is more symmetric, that should be good. We're good to go on that. Is it the same prompt, Cameron? A study of body fat? Is it the same, a study of body fat type question? Okay, let's go find it. Here it is, I think. Okay, so this is the second version. A study of body fat of 250 men collected 12 body parts, as well as the percent of body fat for the men that carried that. The accompanying dot plot is their bicep in circumference in centimeters. For the bicep measurement, would you report the mean, the median, or both? So this is where it gets a little iffy. Sometimes they say report both. You can always report both. It's not a bad idea. But to determine mean or median, we have to look at, and I'm just repeating this, you said it earlier, and we'll throw you more points. Throwing you points now anyways. You have to look at the what. To determine between picking mean or median here, we're going to first analyze the what of this distribution. So before you think mean or median, which is a measure of center, because that's where's the center. Is it the average or is it the 50th percentile? We have to look at the shape. Great job, Cameron, right there. So here we are, and we're looking at it. This is the same distribution we just saw a second ago, and we described it as what a moment ago. So just a moment ago, I described this distribution as mostly what? And I'll delete the monster man, because he's trying to trick you right there. I said this is mostly what? Mostly what? Mostly normal, mostly symmetric. I know you might see a little tiny extra peak over here, but that's not really bimodality. You kind of see where's a strong peak. Bimodal is usually going to have a stronger second peak, where we see two peaks like that for bimodality. You want to see stronger peaks, not little kind of extra bumps in it. It needs to be good, clear, separate bumps. So we're thinking, since it's more normal, report the mean. And let's see, because now the answer, be careful. Remember how we said we're going to report the mean? But look, report the mean, the distribution is skewed. The mean is more resistant to skew than the median. What do you think about this statement? The mean is more resistant to skew than the median. What do you think about that statement right there? The mean is more resistant. That is wrong. The median is more resistant. So the median is more resistant, but the data is not that skewed. So I don't love this. Once again, sometimes they're a little different than me. Report both right here. They're going to be pretty similar, but I would say not my favorite question, but we would report the mean. I would report the mean. I'm glad that you could narrow this down by that, because report the median is wrong, because I would report the mean since it's more symmetric. Then report the mean gives you wrong information afterwards, so you wouldn't choose this. It'd be a bad question if it said report the mean, the distribution is symmetric, the median, the mean is not resistant to outliers, but there are no outliers. So the statements after report the mean are wrong, making choice C an incorrect choice, and choice A and B are wrong because for symmetric distributions, we normally report the mean. Does that make sense, Cameron, right there? Pretty good question, little tricky. These are wrong because we report the mean. This is wrong because afterwards we would not say that. And you can definitely report both, because here's the thing, when it comes to symmetric distributions, yay, symmetric distribution, mean and median. If you take a look at this graphic right here, there's a lot of great graphics on this. When a distribution is normal, let's go copy image address. And so when a distribution is normal, it's a little blurry. The mean, median, mode are all in the same spot, but the mean follows the skew. The mode is where the peak is at, where the median it doesn't really follow the skew, but the mode can usually be, the modality of it can usually be exactly where the peak is at, and the median will be a little bit over to where the data skews. But the mean follows the skew the most. So the median is not going to be impacted by outliers and less impacted by things like skew. We say it's resistant to skew, but your data goes in that direction, your higher 50% is going to be in that direction. So pretty good graphic right here. Positive skew is right skew because that's the higher numbers. Negative skew goes towards the negative numbers, so that's the left. So we just think about our monster men right there. Okay, we got time for at least one or two more. My computer's acting very weird today. I don't like that. Maybe it's a memory issue because I'm running low on memory. You're welcome, Cameron. We've knocked out 5 or 6 questions right here. And they're tricky. You get 5 attempts at this, so I would suggest using 5 attempts to practice, do other versions, see if you get them right. We can always do Canvas contents too. I think, do we have a Canvas content? Do you want to do would you like to do the Canvas content, Cameron? Canvas contents I like are fun. Like they're a lot of fun. When's the first Canvas content due? So we can knock out a Canvas content. Let's look right here what's coming up due. Chapter 2 homework and quiz on Thursday. Data analytics on Friday. Canvas content on Monday for next week, chapter 1 and 2. So, you know, let's open that up right here. It is due soon. It's due next Monday. So if you want, we can do the Canvas content right here, and I'll do maybe 2 versions of it, and we'll talk over the answers and how to solve it. Now, the number one thing to know about Canvas content is this is what the test looks like. I'll get questioned a lot of times. Let me put this right here. People will say, what does the test look like? And I'll say Canvas content. So if you can do the Canvas content, especially without my help, you're doing great. It's not bad to get some help and to see how to do the questions, but Canvas content is what the test looks like. All data needs what? All data needs what? We repeat this like 20 times. So remember how like, maybe I'll start class with this and be like, you know, I did this during office hours and I'll do 1 question or something on this. And I'll be like, if you want to see the rest, go to office hours. So you can just get it done. All data needs what? Context. I repeated that like 50 times and people still get this wrong on the test. And I'm like, no, data needs context. I'll say to students, like, you're getting 2. And they'll say 2 what? And I'll say, yeah, you're asking for the context. Next, we have a blank is a group of people or items that we want to understand. Sometimes it is called the this of interest because we're interested in it. So a blank is a group of people or items we want to understand. So we should be able to define everything on here. So a sample is what we collect and try out. It's not what we want to understand, it's what we have access to. A population is the group we want to understand. A parameter is the thing we want to understand. Like, let's say we want to understand who's going to vote, like what % of people will vote for Biden in the next election. Because we know Biden's running, he said he's, well, in the big thing, or Republican primary, what % of people are going to vote for Nikki Haley, or what % of people are going to vote for this. That's what we want to understand. We collect a sample. The sample gives us a guesstimate, which is a statistic, and the population of interest would be all the people who are going to vote in the next election. So that's the group we want to understand. What do we want to understand about them? What is our estimate of that? And then what do we collect data on the sample? That's the sample we collect. Ooh, so here we go, and we'll need to make sure we talk about this today. Mr. Diggs is a high school principal who is interested in measuring students' opinion on the food in the cafeteria by giving them a survey. During the first period, he decides to randomly visit 12 classrooms and give all the students in the classroom the survey so that all their responses can be collected and included in the sample. This is an example of cluster sampling. Now, we'll probably go to this question during class because this is a really great example of every single type of sampling we could present to you. So a simple random sample is like a lottery where we have a bunch of, no, don't worry, Cameron, 100 points for taking a guess on that. That's really great right there. So simple random sample is when everyone could be accessed. Let me write down these definitions right here and we'll put them on the screen during class too, because we added this addendum to this test. Here we go. Simple random sample. Step 1. Everything gets a number. Step 2. Select numbers randomly. Then we have systematic sampling. Step 1. Start at a random point. Step 2. Sample every kth observation. And then we have stratified sampling. Step 1, acknowledge a difference in your population. Step 2, sample randomly within those, or use simple random sampling to sample randomly within those differences. It's a bigger thing, right? And then last but not least, cluster sampling. Step 1, create or find or create random clusters. Step 2, take a simple random sample of the clusters and do a census on it. Okay. So let's look at this right here. Here are the different ways to do sampling. Let me disappear. But these are multi-stage. Multi-stage is going to be any combination of combining these, or putting these together. And convenience sampling is going to be sampling the easiest things to sample. I think did Terry say we added back in this chapter? Because now it shouldn't be here if it's here. So that's why I got a little bit confused. I'll have to ask Terry because, and let me look at this while we're doing this. So we got a little sidetracked, but that's all right. Because we might have chapter 10 back in, and I gotta say, hey Terry, oh wait, here it is, chapter 10 sample surveys. I'm gonna see something really quick right here. How are you doing, Cameron? What questions do you have? We got a little sidetracked during office hours for a half second, because I'm wondering, here we go, I'm over here. Because Terry said something about chapter 10 back in, and that would make no sense why this is here. And so, prelude to chapter. Okay. The tentative schedule. This makes sense, but I don't remember in the slides. Correct, and that's what I'm currently doing right now, because I might even go run and say Terry. I know, right? That's why I'm like dun dun dun. This is So I need to talk to Terry because this might be a slight error on our part. Because here's the email, I just found it. Because we had to update. There's the thing, I'm showing emails, but nothing private or anything. In the syllabus, under table topics overview, chapter 10 sample surveys was inadvertently left off the list. It is topic that we cover. My lab homework and quizzes, chapter 10 is part of quiz group 2. So the issue here is these questions shouldn't exist. And I shouldn't spend class time talking about it today because that means, so let me go look. This means under assignments, we should see, I'm doing a little housekeeping right here. I should see chapter 10. Is chapter 10 on here? Are we making it up at chapter 10? I need to find Terry right between classes. Dun dun dun. Gasp! I know, right? We've done some switching around of 201 in recent times. Here, we'll finish off the quiz, because then, like, if it's not there, do I cover it? And I'm pretty sure the slides, let's go look at the modules. I'm pretty sure the slides don't have it. I go by the slides. Housekeeping. We're gonna download the slides right here. I need to make it so, well, okay, there we go. I'm not used to slide down one corner. Housekeeping. Someone's like, what are the answers? We'll get back to the quiz here in a second. It's a fun office hours, hanging out, getting work done. This is loading up. I want to get Chick-fil-A for lunch, but man, the lines are long. There is long, long, long lines. We are almost booted up. I am just here for the ride. Well, here's another 100 points. Thank you for being here for the ride, just to hang out, get some work done. My computer's hanging on the load on this. I need to clear out some memory, I think. PowerPoint not responding. That's always good. It's just gray screen right now. But we're here for points. Let me go look. I think I got some space on the computer finally, but I'm switching computers this week. Points. Check out those points. Well, we want to be able to load. Johnson by tomorrow. Oh, here it goes. PowerPoint's doing something. PowerPoint. You gonna do it, PowerPoint? After you finish going over this, can we talk about the data analytics assignment due this week? Yeah, we might have time. That's gonna, let's see right here. Let's talk about the data analytics. What questions do you have about the data analytics assignment? Let me go to data analytics. What questions are you wondering about the data analytics assignment as PowerPoint just crashes in the background for me? Is it gonna load? What questions do you have? And so I have the videos going over it. Here, let's put visual in the chat. I'll pin this. Visual, I think that goes over it. I was a little confused on what to include in the write-ups. Yes. So here, this is the visualization playlist right here. And oh, PowerPoint might be loading up now. Might be loading. Me too, good question. All right, let's talk about visualization to end right here. And so here we go. Let's put the new timestamp in here with visualization. Thank you so much for being here, Abigail. We'll throw some points. We'll make sure everything's running by the time we're back up and going. We did a little bit of the Canvas content and trying to find over here. Okay, so let's put a note in here. 5143 and visualization 2. Okay, so let's talk about what you'll be doing in your visualization. So if you're watching this right now, I've made some videos that go over the visualizations. This is from the old studio right here. I'm gonna drop this in the chat. It's also what MuBot just put there with the visualization playlist, so you can see what to do. So when you make a visualization, and these are the steps on how to make it, the visualization assignment might be a little bit different depending on the semester to semester. Go up here to HD quality. So with this, I want you to think about this. In your write-up, what are you supposed to say? Because that's what a lot of people wonder. Like, think about this distribution right here, and we probably had the numbers above it, which we did. What would be something good to say about this distribution? So if you're talking about this, and this is a bar chart, because it's categorical, it's what genre was the movie, it's a bar chart. So this is a bar chart. It's what category was the movie. What could we say about this? You've got the frequency and the relative frequency. Think about what you might say. And it might say, put it in ascending order or descending. Well, here's the thing, a good answer. This one doesn't actually have shape because there's no technical order to it. There's no peak to it because that's for histograms. Good answer is Cameron right there. This is a bar chart. Histograms have shape, center, spread. It kind of looks like a histogram, but because the number line is categorical, it's not really a number line, it's a bar chart. Even though sometimes it will say histogram and jumps, this is a bar chart right here. And so we'd say something like the most common, Aaron, good to see you right there. How I know that univariate categorical pie charts, pie charts, what am I stuck with as factors? Do we know which one would be better? Generally, we like bar charts. Bar charts are kind of good because you can see which one is higher. Sometimes it's just no, good question, Aaron, right there. Bar charts are usually more preferred. Pie charts are not bad. It can be either or. Like if you're doing my Pearson question, it's like which one's better. There can be benefits to each. Some people like pie charts, but I'm more of a bar chart fan. So if you look at this right here, you can see that the most common movie genre is dramas, with comedies being next and documentaries being third. And you would cite the numbers. Like the most common movie genre was dramas with 227 movies. This accounts for about 31% of the data. Do you see where I'm getting that 31 from? About 31% of movies were dramas. The next common movie category was comedy, followed by documentary. Comedies had 140 observations, which was 19.2% of the data, and documentary had 18.3 or 18.4% of the data. The next movie genres are lesser and only account for 66, 49. We could put them in order right here and mention them. It's a lot to mention. You might not mention all of them, or you could say the least common movie genre was horror, which was only 30 films, which account for about 4.1% of the observations. But does that make sense what you're saying? You need to quote the numbers, like most common group, least common group. So that's what we're talking about when we're saying how to explain the data. I would maybe do it. It doesn't hurt. Like the graders should never take off for you writing too much. Border on writing too much than writing too little. If you get points off for writing too much, as long as you don't write something incorrect, they shouldn't take points off. There's nothing wrong with being thorough. It's just showing you understand it. Of course, if you're working for a company, I'd probably write what I wrote right there for a company. I would say, or I'd ask them, do you want me to do percents or counts? Like, because percent is relative out of 100, where counts shows you the amount. So I'd say, do you prefer percents or counts? Nothing wrong with doing both. I think the write-up, if it doesn't say, just use both. Doesn't hurt. And then you understand this is a count right here, and that's a relative frequency over on the other side of it. That's the relative to 100% or decimal. Now, when it comes to histograms, histograms are a little bit different. So there's a bar chart right there. Here's a pie chart. Notice the pie chart has percentages. So when you're describing a pie chart right here, this is a pie chart showing us the movie rating. I do one, it depends. One decimal is usually good. Michael, good questions right there. So, and thank you everyone for being here. Just jump in and ask questions anytime, just like that, Michael. Great work. Let's throw you some points. So I would usually do 1 to 1 decimal. Graders shouldn't count off for that, and unless the assignment really says it, 1 decimal is usually good. Companies might say, 14.1, just say 14. Nothing wrong with adding an extra decimal when describing it. So, if you want to do 2, nothing wrong with that. If a grader's like, you didn't add enough decimals, unless you're rounding really big, I don't think there's a problem. So right here is the movie. Make sure to click done on these. A lot of students don't click done on their graphic. That's the most common error, the done button right there. People don't click it. You're welcome, Michael. And so usually I see that they haven't clicked done, and you notice when you click done, it goes from, you'll see me do it in the video. You'll notice, I'm probably talking in the background, let me do this. You see it goes to an actual graphic. You can actually click any of these things where it says like graph builder and change it, which is nice, makes your graph look better. So that's a pie chart right there describing movie rating, with the most common movie rating being not rated. Well, that's interesting, which is 35.5% of the data. Next, we go right here, and then I would go through and talk about least common and such. Next, we go through here and see a histogram, and very, very clearly, this histogram is what? Well, I drew it right there for you. Very, very clearly, a histogram is what? What does it mean? Say a short write-up of the visualization, a tool you believe is the best format to inform the reader. I think it's worded weirdly. I think what we're getting at right there is like, write it up and explain the important things. Not skewed to the left, though. Right to the high, left to the low, whatever way the monster man's tail goes. It can look confusing, so I think we just want you to go through and give a full explanation of it, Abigail, right there. Good question. I'll double check with Terry, but look at someone asked that in the Discord, and I pointed them to the key or the rubric, which explains. It can look left skewed right there, but remember the high numbers is what way the tail is pulled towards. So if you think that looks left skewed over there because you flip it down, it's because the number line is reversed. When you turn it on its side, it is right skewed, and the number line should go from 0 to the high numbers. So that is a right skewed histogram right there with some extreme outliers. So this data is right skewed. Proper measure of center and spread would be median and IQR respectively. And then make sure to give the context. If I were to explain this median, I would say the median for the tickets sold in millions was 0.02, which represents the 50th percentile and is about 20,000 tickets, because that's 0.02 in millions is about 20,000 tickets, because 0.2 million is 200,000, 0.02 is 20,000. So the 50th percentile of tickets sold in millions, 50th percentile is medians, is 0.02. The IQR represents the spread of the middle 50% of tickets sold, which is going to be these two numbers subtracted right there. We're going to subtract those and get about 0.417. You can subtract those numbers, and that is the range of the middle 50% of movies sold. The range of the middle 50% of tickets sold in millions goes from 0.003535 to 0.42055585, which is an IQR, which is an interquartile range of 0.417. Does that make sense right there? We want to give the numbers, we want to give the context, we want to say the IQR is the range of the middle 50%, we want to say the median is the 50th percentile, and then we don't want to give the mean or the standard deviation because this data is skewed. Now, if the data was normal, we would want to give the mean and standard deviation and not give the median and IQR. How are we doing on that? Does the visualization look a little bit easier? Also, once again, check out these videos right here where I show where to click and jump. So we were kind of talking more through the theory right now. So if you're wondering where to click, these videos are going to show you every click to do, and then you'll have me talking through what it means and giving kind of similar explanations right there. Any other questions? Oh my gosh, it actually opened up. I'm pretty sure we removed out the sampling portion because these are the notes. Dun, dun, dun. Well, let's throw 100 points for everyone who was here. And we'll be starting class soon. And we need a new intro for today. Let's go to openings. And what is a good one to start out with today? I don't know if we've done Shattered Original. So Shattered 2. So with this, good to see you, Drew. We're going to end office hours for now. Bye for now, everyone. See you in class here real soon, about 18 minutes. Bye.